Hello everyone, I'm Vincent, and I'll share with you our experience on building the Disco project, which is a model application built with Theia and EMFcloud technologies. Our agenda: first, the context in which the application was built, then features we need for the Disco application, a walkthrough to build such a model application, finally, a recapitulative of my tips. So the context. Disco is a modeler for editing satellite databases. It's a new framework built to replace BEST, which was old technology. It supports modeling and transformations of space databases. For this new framework, built with EMF, we needed a new UI, a better UI, which is based on web technologies since it's the state of the art, but also with offline capabilities, since one of our requirements was to use the Disco toolkit as a standalone desktop application. For the UI, we have to use the Disco core architecture. The user needs an HMI, of course, but this HMI has to rely on the Disco broker component, which manipulates the model in EMF. We also have a Java programmatic API exposed by the broker. And the broker can eventually delegate some heavy jobs to a domain server on a server machine with boosted capabilities, and eventually store the model in an EMF CDO persistent server, which allows to use database storage for EMF instead of files. The Disco frameworks, before the UI, manipulates big models. It stores its domain intelligence in profile definitions, which means we have meta models which are dynamic without generated Java classes. It has faceted elements. Some of the properties are virtual, not stored in the model. It supports multiple domain formats for live transformations, imports, exports between these formats. It also has X-text expressions, but with textual elements referencing non-textual model elements outside of the expression. So it's not a small framework, it has complex problematics and a complex architecture. Why using Theia and EMF.cloud? It's all Eclipse technology, so we have a consistent ecosystem with compatible licenses and technologies. We use EMF X-text, and it makes sense to look for the cloud version. It has Electron support, so we can have offline usage, which is not obvious with web technologies. It has workspace management. It requires only a few adjustments to present what we already had with the Eclipse workspace. It's highly customizable. We can rip off some parts, add whatever we need. So it was the obvious candidate for the Disco UI. The features. For most features we needed, we found a corresponding solution in Theia and EMF.cloud. We needed a basic explorer to see our workspace. This is supported natively by Theia. Also, tree views, including with columns. We looked at the Theia tree editor module, and we were able to customize it to support columns. We needed properties editor forms. This is supported by JSON forms. And expression editor with X-text. And the Monaco editor can be used to edit expressions with an LSP server, which can be implemented with X-text. So that's a perfect match for our expressions. We wanted to show validation reports, the global results, and also detailed entries with navigation to concerned elements. Theia notifications can be used for the global results, and the problems view looks adequate for the detailed entries. We wanted preferences per project. They are also managed by Theia. So we refactored Disco just a little to support Theia preferences format. Custom wizards and pop-ups. That's the basic any UI framework can support. So we can use Theia's dialogues with React or Material UI components. We haven't implemented it yet, but in future versions, we need diagrams, both simple boxes and rows diagrams, but also more complicated ones like the sequence diagram. There's a solution for that with a JLSP and Sprotty. Something we call an encoding view presents the messages bits as timeline or grid with a fixed length. We think JLSP and Sprotty can handle it too, even if we've been looking for better candidates. So here's a short demo of the Disco application. We start by creating a workspace. So this is a classic Theia workspace. Except in this workspace, we have projects. We want Theia workspace organization to be separated in projects here, something stricter from what is possible in Theia. So we can use always workspace project preferences and avoid confusion for the end user between the workspace and the project. Then we import a model from a classic Disco file. And this file is converted by the backend framework. So it's imported and converted to the Disco format. Then we can open it, edit it with the properties view. So there are several JSON forms integrated in our properties view, not just one. We also have actions to open extra views with extra information. So here is the most complicated preview we have. This has columns and it has a complex content logic. So the children you see is not the children in the model. These are reference elements. These are complex references. We can also create new data nodes. So we go back to the main tree view to add new nodes. We can also add nodes in other tree views. And we can edit expressions which are formalized with Xtext with the LSP support. So we have auto-completion, everything that comes with an LSP. We also have a global validate action. The validate action over there, we'll click. And this validate action launches the backend EMF validation. Then the backend reports some status and we create markers which are logged in the problems view. And these markers in the problems view allow to navigate to model elements so we can find directly the elements causing the error. There's also a search view which can be used to display elements dispatched everywhere in the model. And this search view also allows navigation. So this is a sample of everything we can do with Disco application and the technologies we used. A walkthrough on how to build a model application such as Disco on a complex model framework. After reading the doc, you can start exploring some code and play with demonstrators. The Coffee editor is a very good starting point with lots of EMFcloud features. Then that's my first tip. You can use Gitpod to quickly explore repositories, compile, and execute them. You don't have to install anything on your computer. You just open the GitHub repo in Gitpod, and voila, you have it in a Theia environment. This will help you make prototypes or mockups by modifying the Coffee editor, for example. Now, the global Theia architecture that you must understand. There's a Theia frontend and a backend, both implemented in TypeScript. They communicate through JSON RPC messages over WebSockets or REST APIs. If you want to use extra technologies, Theia backend will connect to the corresponding servers offering services like the model server, the LSP, the GLSP. Whether backends are deported or executed on the same machine locally, that's up to you, and this gives you a lot of possible deployment configurations. For the servers, it's important to have a single source of truth, as explained by Maximilian Kogel at EclipseCon 2020. You must not load the same information twice, nor edit it independently from different locations. To achieve this, there are two solutions. You can either use interconnected servers, which rely on the EMF model server, or opt for one big server, which exposes all services on top of the same model objects. With our framework, because we have a lot of Java services doing difficult stuff, it was easier to provide one big server with additional services and LSP on top of it. You should also be able to navigate in complex frameworks, Theia, EMFcloud Model Server, Xtext, Inversify, React Material. All these technologies are not always intuitive, and you may have to muddle your way through the code sometimes. If you're building a new team, foster on profiles with general experience, whether on specialized front-end profiles, or developers with full stack or backend experience had less difficulties in developing with Theia, because it may prove hard for inexperienced front-end developers to work with Theia framework. For the Electron development environment, if you want to make an Electron application, you must build your Theia's application with native node modules. So these modules have to be recompiled on the same OS. So you can't build a Windows Electron product on Linux. For Windows OS, you'll need Visual C++ build tools, which you can eventually get through the Windows Build Tools NPM module. This module does, in the end, download Visual Studio. So ultimately, you have to care about the Visual Studio license. You may see on some websites that the community license is free. That's the case only for open source projects, which was luckily our case. But if you want to build a proprietary application on Windows, you have to pay a Visual Studio license, or this will make you a pirate. On a great article that I suggest you take a look at for starting, Jonas Helming tells us that the EMFcloud model server is not a new persistence. You can use any existing persistence you want, including EMF resources. But when you confront to the reality, here's another quotation from the default model resource manager source code. So that's the default resource manager implementation. For non-Java fluent people, it means that if the model URI is not a file, we'll use a file URI instead. So we can't use a non-file URI. So this means we can't use CDO URIs. Did Jonas lie to us? No, he didn't. That's only the default implementation, which you can, of course, override, but you'll have to do a little extra development to use any protocol you want. It won't come free. If you have a complex framework like CDO, you want to plug the model server on top of your own framework. So first, you start everything you need for your framework. Then you create a model server, you configure it, and finally, you actually launch the services. Everything else you need to configure, you'll be able to change with juice bindings. You just extend the default Google Juice module and overwrite whatever you want to change. Especially, you'll most probably need to override the model resource manager, not only for the UI protocol limitation we saw earlier, but also because the default implementation loads all models in your workspace at startup. This can be critical for big models and big workspaces. Also, you may want to use custom editing domain and resource set from your framework. The model server interfaces use specialized implementations instead of the standard interfaces. That's probably worth a pull request here. But you can overcome this by using a subclass with the extend delegate annotation, which delegates all methods to your implementation. The code moves very fast, so if you customize a lot of things, you'll probably have to do some refactoring sooner or later. But that will be for the greater good, since it usually simplifies your code. Also, you'll probably want to override the Codex. It's no easy after a pull request I made. In your custom Codex, you can add lazy loading. We use a custom compiler in JSON encoding and replace containment references we don't want by proxies. This way, you can control the granularity of objects you want to transmit. For example, our model is organized with data and sub-elements. We just filter out the children data, but not the sub-elements describing the same data. You can also migrate the IDs from XPath to XMI or CDO IDs. The decoding works fine by default because it's loading objects from your model resource. And for the coding, we take a compiler, the same that we customized before, and report all IDs from the original resource to the JSON transmitted resource. Martin Fleck from Eclipse Source has done a great job on custom commands. So it's not easy to define new ones to edit the model. You'll just have to bind a new codec in which you implement the toServer method. I suggest your server EMF command extends the recording command class, so you don't have to worry about undo and redo implementations. On the front end, when creating a command, you must always set an owner of the serialization will fail on the server. In case you need advanced attributes or not just values in your command, you can define an eCore command meta model. You inherit from the command E class in the framework's meta model. You can look at the generation options to have the C prefix and generated classes, just like in the model server plugin. I suggest you use your E class name from the package class as your binding key. Finally, you just copy your E class knowledge to your Theia plugin to create a new model server command, and voila. You can use your model server command from the front end to the back end. Now, what I call the synchronous nightmare. It occurs when you must implement a synchronized method with returning information you get asynchronously. So the two interfaces can't match. The easy way to solve it is just by changing the interface you implement with a maybe promise from Theia. EMFcloud is still young enough, so you can do it whenever it makes sense. Here's an example of a pull request where I did so. In case you can't, if you do override Theia core framework method, for example, you can work around it by finding an asynchronous method called beforehand and storing the promise result somewhere. So in our code, we have such a manager we call when data are loaded to execute registered job collecting asynchronous information. The model validation was introduced in the model server API by Simon Guabant when we were needing for it. So this was perfect timing. The API reports diagnostic objects whenever a validation is launched. Then we log these diagnostics in the problems view. This integration was contributed and documented in the model server markers Theia module, so now you can use it too. Model server has something called live validation, which is not at all the same as EMF live validation. I suggest you disable it for big models, or it will launch the whole model validation at each modification. If you use EMF live validation, you will have commands which execution fails with cancel. So we override the execution result with collected errors on status. We return the accepted 202 error status when it occurs, and we hijacked the model server live validation events and use it to broadcast our live validation results. We also exploit this with a special command we call transitory. We use it to validate without steps. So the step validation is performed backend with EMF live validation. The command is always cancelled, and so we never modify the model. We had a problem with a race condition between edit and refresh. So this is what occurs in the Coffee editor. So it's not only our application. You can see when we type 1 to 9 that there are 3 digits missing. So some of the typed information disappeared. Now what happens really is that you start typing text, you type text again, there's a debounce, so the two events are batched and a single modification is sent. That's fine. Now that updates the model on the model server backend. The backend tells us that the model was updated, and we refresh the UI on the Theia frontend. Now, the problem occurs when you start typing text and sending modification events in between, because you have conflicting modifications events and notifications. But it can get even worse from what we saw. With our complex framework, we start typing A, B, C, and on this early prototype, you can see that the model oscillates between A and AB states for quite some time before it stabilizes. So we solved this using deferred and from Theia and Mutex. We added an ID in send commands, and while the command has been sent, we wait for the corresponding model refresh notification and delay any new update in between. In case the model server is never refreshed, we handle this as an error. And this is what our final UI looks like. It's fluid for the end user. You don't get interrupted. There's still a deadlines, so not every character typed ends with a model server notification. And you can delete the text and everything works fine. A recapitulative of the tips. Use Gitpod. It allows you to explore Git repository quickly to run examples. Foster on profiles with general experience. Beware, the Visual Studio license can be very tricky. Use extend in backend implementation, especially the delegate method. The delegate annotation can help you for overriding implementations. Be prepared for slight refactoring because the code moves very fast. Use C commands. Extend the recording command for your EMF command. Use a class name as juice key, and always set an owner on the front end. Extra tips. If Theia won't start, if you keep up the wheel turning, look for DI errors in your console. If you have dependencies updates, inspect the yarn log file for changes, and use selective version resolutions. This helps you setting particular versions in your JSON module file, and this will help you to avoid conflicts with conflicting versions. We can be very tricky with injection dependencies. Also, if you use JSON forms and want to edit them, here's an application that can help you edit quickly on the web before recompiling your application. Watch for new repositories on EMFcloud. Here's an example, the properties view. That's a repository that came very late, and we weren't able to use it because it arrived too late. We already had a functional properties view, but this can be very promising. Tips for using EMFcloud. The components are still young enough so you can change the API, so make it better for you and for the others. Do participate, please. People at Eclipse Source are very welcoming, and it's important that we build a larger community on these technologies. There are many ways to participate, so do not hesitate. Ask questions when needed. Take time to reply when you can. Make suggestions when you see room for improvement. Create documentation, tutorials for newcomers, and if you have competencies, you can submit pull requests, but you don't have to be at this level of competence to participate. So join the community. We need more adopters, more contributors, not only coders, and a more diverse community. Eclipse Source does an amazing job at animating this community, but it's important that other companies also engage for the sustainability of this community. Why are not all these suggestions contributed to EMFcloud yet? Some are too customized for a framework, so too linked to Disco framework. And mainly, it's a lack of time and tight budget. So making the tool work was our priority, and the potential contributions we could make are not always stable. Special thanks to people who make me feel welcome on EMFcloud and review my contributions and suggestions. So there are Martin Fleck, Nina Doshek, and Lucas Kohler. And thank you for your attention. Please do evaluate the session in Swapcard and join the conversation at EclipseCon. I am available for questions. Feel free to ask anything you want. If you have difficulties with your application, some problems you want to overcome, please share with me. Thank you for staying this long. A little erratum about Gitpod. I learned just on Monday that Gitpod launches now VS Code and not Theia. It used to launch VS Code, but now it's VS Code. about the questions. So are you planning to deploy Disco as a cloud application as well? It's not part of our client's requirements. So we develop the application for the CNES and the CNES decides. But it may be envisageable, it may be possible in the future. It's something that we have considered. But since the backend server is a mono client, we need a workspace management that we could implement with Qi. So there would be EV refactoring to support this, but this is something that we considered. But it's not part of what the clients wants for the moment. So time will tell. How does the developer experience with Theia and EMFcloud compares to the traditional Eclipse RCP with respect to flexibility, modern UI, vs maturity? Definitely, the EMFcloud is much more modern. You have some things that you can do much quicker than with RCP because they are much more modern technologies. But the drawback is that you do not have the same maturity, of course. RCP has decades of evolution behind it, so we do not have this maturity yet in EMFcloud technologies, but it's growing very fast and things are fixed very quickly. So I think it will get mature very soon enough. But yeah, for the moment, you can encounter some bugs and do not hesitate to raise this. Next question. What are the biggest challenges you faced when mapping the functionality from desktop to web? And do you foresee any major problems going forward with more complex features? For the Disco application, we started developing only the backend with only a stub UI based on RCP at the beginning. The reason is because the client decided to develop the backend on one hand and make another call for offer for the front end, which could eventually be given to another candidate. So we started with a background. We were unsure of what the UI front-end technology would be. So we just plugged and added the service we needed. So we did not meet a lot of challenges because we had nothing to migrate for the UI. We only had new endpoints to add, but nothing difficult for us. So there was this clean separation, which you don't always have. But yes, that's a question that has come often about migration of tools to the web. The biggest difficulty is to have a clean separation between the UI and the model intelligence and the backend. What would you wish the community of Theia and EMFcloud would focus on in the next years, and how do you think we can get there? What we should focus on for the coming years is fixing bugs, making things more robust. And I think most important of all, to enlarge the community is to provide quality documentation. So that's the reason why we need newcomers, which are not only developers and people who fix the things they need, like me, but also people who can post tutorials and things for newcomers so that we can overcome this steep learning curve. Can the LSP integration of JSON forms be contributed generically to EMFcloud? It's not that easy. In fact, our LSP integration in JSON forms is quite thin. This is a custom widget for JSON forms, which only delegates to a Monaco editor. So there's not much on the JSON form side. And which is more complicated is the fact that we have a special command for setting our expression, which is based on how our metamodel is built. So it's not generic at all for this command part. But the UI part of delegating things to the Monaco editor is very thin. and very simple to implement. Where can I find the slides? The slides are not available yet. I can post them. I will surely post them on the EclipseCon page. And thank you. Bye.